So these are gonna be made by a molecule of glycerol, which is CH2. It's got a 3-carbon skeleton, so it's gonna be C, C, C. Then CH2OH, CHOH, and here it's gonna be again CH2OH. So it's pretty simple as a molecule. There's carbons, 3 hydroxylic groups, and the hydrogen changes because this carbon is not bound to any other carbons. This one isn't either. So the only one which is bound to other carbons is this right over here, which only has one H. Carbon must have must have 4 bonds to be happy, let's say. Carbon monoxide has 2 bonds, but it's luckily hard for it to happen. It happens like in fires when there's not much oxygen, but living creatures do not produce much of this. It's really very scarce or almost null. Anyways, what happens is that these OHs, I'm just gonna take one for example, this right over here. It's gonna bind with the carboxylic part, which is this part over here, OH, and O with the double bond of the fatty acid, which I'm gonna represent like R. Okay, that's an R. Remember that R, it means this right over here, which can vary. I mean, it can be longer, shorter, or whatever. It can even end like right over here. Anyways, it's gonna be CH2, 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 and CH3 at the end. So what happens is that one molecule of water is gonna go out. So this OH right over here plus this hydrogen right over here is gonna go out as a molecule of water. So let me write this arrow. This is to indicate one molecule of water is going out. You can see H, O, and H. It's going to make water. And you're going to have CH2. And then this is the important part. It's going to bind with an O and with a C, which is bond with a double bond to an O, and then your lateral chain. Now, let's make another lateral chain. This R1 represents this part right over here, because there would be a lot to write. So let's just get concentrated on the one reaction. This molecule, by the way, it's called monoacylglycerol. This is triacylglycerol, tag, or triglycerides. It's the same thing. This can also be called monoglycerides. It's just got one fatty acid bond to it. Now, what does ester mean? It means exactly this over here. This is an ester bond where you're going to have R1, O, C, double bond with O, and another R. Now, this is an ester. Wherever you're going to find this is an ester. It's just the name of this type of bond, which has particular properties and everything. Remember, this is going to be a partially negative charge, because the difference of electronegativity is more than 1, yet less than 2. So this is going to happen, this bond, for all 3 of these carbons. And it's going to become a tag, triacylglycerol or triglyceride, with 3 other fatty acids, with 3 fatty acids bond to each one of its carbons. What can happen is that just one more of these is bond. So there's going to be a deacylglycerol with 2 fatty acid chains. And this OH right over here, it's gonna bind with a phosphate, inorganic phosphate, and then can bind another molecule of, for example, choline or any other polar group, and that is gonna make, that's gonna form a phospholipid. So we have two major categories, which are tags, triacylglycerols, which are the form in which most of our fats in our body are stored as triglycerides, and then phospholipids, which are the major constituents of many of our cell membranes. They are very important for living creatures.